Hey, this is René, and in this video you will learn how to write code for the MetaTrader 5 trading platform, even if you are an absolute beginner and even if you never touched code before. Also, when I teach something, I always want you to understand how things work. So you will not only copy my code, but I will explain everything in detail. And this is super crucial to really understand how coding works, so you will be able to write your own programs in the future. So make sure to watch the whole video from the beginning to the end. Do not skip around, do not jump around in the video. If you need more time, and I know this video has become a little bit longer, if you need more time, pause the video, come back at another day, for example, but do not just jump around. It will not help you. Also, I will put timestamps so you can always come back to this video to watch the parts again if you need some assistance with your own coding. So save this video already. If you stick around and watch the whole video, you will learn all the essential basics like variables, data types, control structures. You can create your own functions, etc., etc. You will really know how the MetaTrader 5 framework works, what you need to do exactly to write your own programs. This is a skill that is so important if you want to become a successful and in the best case automated trader. I was not able to trade manually. There was just too much mental stress, negative factors, etc. that kept me from being profitable. But this changed with automating my trading strategies, and I heard this from many of my students already. I taught hundreds of people at this point how to code successfully for the MetaTrader 5, and many of my students write their own programs. Some of them even provide coding services for others. So I think I know one or two things about teaching how to code at this point, and this is what you will hopefully experience in this video. So have fun watching this video. It's really a great chance for you to learn how to use the MetaTrader 5. So let's start right away with the coding. So to demonstrate you the strategy, to explain quickly what we will create in this specific programming tutorial, it is a really simple strategy which follows some kind of Donchian channel logic, if you heard of this indicator before. So we always take the highest point of the last X bars, usually something like 20 bars, for example, and then we wait for the price to rise above the high of the last X bars. So for example, here at this point it happened, and in this situation then, if this trigger is here, we open a buy position. Then we try to follow a long trend. Of course, we do have a TP or a stop loss in place, and we can also use a TP in this strategy, which you will learn later in the programming part. But one most important concept here is the trailing stop loss. So this first trade was not successful. It was closed in the stop loss, but here you can see the second trade is already going a lot better, and you can see that as soon as there are more candles going into the right direction, the long direction, we will trail the stop loss at the low of the last bar plus a specific buffer percentage. So you can see the stop loss, if there is a long trend, will be trailed along until the trade is closed at the stop loss. So this is what the program always does. So it's a really simple strategy, but I think it can be really effective, or it can be a good basis for effective strategies in markets like the US 30, the US 100, or NASDAQ, or any index pretty much, or any market that has long-lasting long trends. For example, also stock CFDs. So these were just some example trades, so you know how the strategy performs, and now we will have a look at actually coding this beauty. So let us now start writing the code for this specific strategy. So the first thing I want you to do is open the MetaTrader 5. You probably know this platform if you are a trader already. So in the MetaTrader 5, we have an integrated development environment, or in short, IDE. We can find this in the MetaTrader 5 toolbar up here, or if you do not find it there, you can go to Tools and then click on MetaQuotes Language Editor. This will open the IDE for you, and this is the environment where we can write the code for the MetaTrader 5, and more important, we can compile the code for the MetaTrader 5, which means that we take the code that we can read as a human being and translate it into computer code or an executable program that the MetaTrader 5 can use to apply our strategy in a chart or at a symbol. So what we do next is we want to create a new program. So in the upper left corner, you should find this new button. And if you click it, you will get to this option menu here. We want to select the Expert Advisor template. It's usually pre-selected. Then we click on next. And here we have to choose a name. And I will call this Donkian Channel YT for Donkian Channel YouTube. You can choose any name you like. We have the author, link, and some parameters here, but we do not use this, or we do not change this because it's a lot easier to change this later in the code if needed. Then we click on next, and here we can choose some predefined event handling functions. So we can choose to add them to our code. If you know that you will use one of these functions, I don't think we will cover it in this tutorial, but you could check these boxes. But even if you do not check any boxes, no worries, you can add everything later in the code. This is the great thing about coding. You can just add the code at any time you need it. Here are some more tester-specific event handling functions, but it's the same. You can add them here already, but you can also add it later in the code, and it's not even complex or complicated. So usually I do not add any of these and just click on finish. And this creates a new Expert Advisor for you. So new Expert Advisors generated with a template always look like this. So you have a lot of these gray lines. You have some properties. You have more gray lines. You have some of these, we have 3 so-called functions, which are also event handling functions. So we will get to this in a second. And then we have some of these gray lines. So let's have a look at the gray lines first. The gray lines here are always comments. What does this mean? This means that these are comments that are only relevant or important for the programmer. So even if I write some BS stuff here, it does not matter. It does not have any impact on the program at all. So if I now use this compile button up here, and if I click it, this is exactly what I explained before. Once I click on this compile button, the program or the computer or the meta editor and the compiler that is built in, it will take this source code, this text file pretty much, and it will transform it to an executable EX5 file. So how does this look? I can visualize this, and this is what I like to do for myself also to make me or to make you understand what's happening. You can right click up here on this Donkian Channel YouTube or whatever name you chose program, and you can go to open containing folder, and this will open the experts folder of your MetaTrader 5 that you are currently working in. And here you will find all of the programs, and you can see, for example, I do have this Donkian Channel YT.mq5 file, and this is exactly the same name as this text file, and this is the text file that we are currently working on. Then above this we have the Donkian Channel YT.ex5. EX means executable, and this is the executable file that we will then see in the MetaTrader. So if you go back to your MetaTrader, and here in the navigator on the left side usually, if you do not see the navigator, you can open it by clicking View Navigator. Here you will see the expert advisors, all of your expert advisors in the navigator, and here you will find also the expert advisor that you just created. This is the EX5 file. So what happens if I delete the EX5 file here? I delete the Donkian Channel YT EX5 file, and now if I go back to my MetaTrader 5 and refresh here, you can see the file is gone because I just deleted it, right? So in the MetaTrader, you always see the EX5 files. So since I deleted the EX5 file, we have to get it back, right? So here in the Meta editor, again, I do have the MQ5 file. Here, there's no EX5, but let's see what happens if I click on compile. If I click on compile, you will see the EX5 file will be created here. So I think I also have to refresh this. Wait, how do I refresh this? Let me just refresh it up here. So you can see once I did this, the EX5 file is back here in this experts folder, which means that it will also be back here in the MetaTrader 5. So this is the relationship between source code and executable. And everything is done using the built-in compiler. So the compiler is the tool that takes the human readable source code, the MQ5 file, and turns it into the EX5 file. So I'm sorry if I'm explaining this in detail, and I know this takes a lot of time, but for me it is important to really understand, and this is also what I build my programming tutorials on. It's really the understanding of what is happening in the computer, because this will make it less abstract and more understandable, because coding is not something that is super weird or complex, or you cannot understand it, because it all follows, it's just 100% logic. So now that we have this MQ5 file and we learned already that these are comments that do not have an impact, I can delete all of these lines and compile, and it doesn't change a thing. But if I write something up here and try to compile without making it a comment, we get an error message, because this is not correct code. So to make this a comment, we just add these two slashes here, and then if I compile, there's no error, and this will work, and the compiler will simply ignore these lines because there is a comment. You can also write multi-line comments, and they look like this. So if I write multi-line comments like this, it will be completely ignored by the compiler. So multi-line comments start with a slash and the star, and they end with a star and the slash. So this is for comments. Do we need these comments? They're not important for the program, so you could delete all of them. If you feel like they help you understand your code later on, or if you work with multiple programmers on the same code, it's definitely a good thing to use comments. Maybe I will use some comments here in this tutorial. Wait, let me not go too quickly here. Okay, so if we delete all of the comments, we can still compile and there's no problem. Then we have these three properties here, and let me explain what they do. So in the MetaTrader 5, we already realized we do have this Donkey and Channel YT executable file here, and it's visible. Since it is here, we can also use it in a chart. So I could use this Donkey and Channel program and drag it on any chart where I want to activate the program. Of course, it doesn't do a lot because we didn't really add a lot of code, but we could activate it already and it would just do nothing. But we could activate it. And what I want to show you here is that we see this copyright 2021, meta quotes, blah, 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 and there's a link behind this. Where is this coming from? This is coming from the properties. So if you go back to the code, you can see we do see the copyright here. So if we change this to 2024, for example, and here you could write your name, for example. I will type my name, and then you can have a link. For example, my website. And then you can change the version. Like this. So if I now go back here and activate the program again, you can see this has changed. There's a different version number. There's a copyright, which is now the current year, and my name. And if I click on this, it will open my website. So this is really cool, isn't it? Also, by the way, since we are on my website already, this is a really cool website. You should check it out. You can get free trading journal here, free expert advisors. I will explain how it works. But the most important thing is in this top menu, you will find the MetaTrader 5 Masterclass. So after this coding tutorial, if you think that my style of teaching is good for you and you want to learn more advanced stuff about MetaTrader 5, definitely check this out, because you will learn everything you need to know about MetaTrader 5 programming that can make you a fully automated trader. But let's get back to the code here. So you can see these properties just change these basic informations when you start the program. So do you have to change this? No. Can you change it? Yes. You could also just delete everything and it still compiles. So you don't need it, but it's a nice information, especially if you or if you plan to sell your program or ship it to other traders. It's cool to have your credentials here, so everyone knows who created the program, who put in the work. But yeah, so this is for the properties. They are these specific properties are just information for the user pretty much of the program. There are more properties in MetaTrader 5 coding. Some of them are actually have a impact on the program, really a functionality, and you use a lot of properties, for example, if you create indicators, but I will not dive deep into this topic because this tutorial is about creating this expert advisor. So what else do we have? We have 3 more functions left. And these 3 functions are so-called event handling functions. Usually you can say that something is an event handling function because it is color-coded in this violet tone here. And also it usually starts with on something because it reacts or it is triggered on or by a specific event. So what do we have here? We have a onInit function, a onDinit function, and a onTick function. What do? They are triggered, as I said, at specific events. So whenever the program is initialized or activated, it will trigger the onInit function. What does this mean? So as I said before, we can activate our program on the chart already. So let's do this. Let's take the Donkin channel program and let's click on OK. Oh, by the way, you can see the properties or the information is now gone since I deleted it in the code. But if I click OK here, you can see in the top right corner of your chart, it now says the name of your program and there's this little head. This means that this program is currently running on this specific chart. In MetaTrader 5, one expert advisor, one program is always attached to one specific chart. So there's no possibility, or it's not able to add multiple programs on one chart, but you could, of course, open another, let's say US 30 chart and attach another expert advisor to this chart. So now this specific program is running in this chart, which means that whenever something happens in this chart that might trigger one of these event handling functions, the MetaTrader will then have a look at your specific program that is running in this chart and it will execute the source code or the statements, the code that is inside of this specific event handling function. What does this say? For example, if we are in this onInit function, we could say whenever the program is initialized, we want to write a text message in the expert's journal. And we can do so using the print function. And it's a very simple function. Let's just type onInit here. So if I compile again, you can see I now added something in the so-called body of this function. The body is always wrapped by these curly brackets here. So you can see we have the opening curly bracket and we have the closing curly bracket. By the way, the exact placing of these curly brackets is not really important because the programming language is not, I think it's not space sensitive or something, or the spacing or the exact positioning of these brackets is not important. So if I move the opening curly bracket, for example, here, I can still compile. If I move the closing curly bracket here, I can still compile. It doesn't change the code or the outcome. So what you will often see, for example, is a curly bracket placement like this. The opening curly bracket after the function name and the parameter list, we will get to this later, and then the closing bracket at the very beginning of or after the last line of the body of this function. This is also the type of placement for the curly brackets that I personally like. So in my code, you will often see it like this. But this, again, it doesn't have an impact on the program. So what else did I do? I added this print function here. And the print function is also violet coded because it is a predefined function. It is part of the MQL5 framework. We can use it right away. We don't have to write it or code it on our own. And then we can see that this print function also has a parameter here. So after calling a function, you always have to open the parameter list, or you have to provide the parameter list. And some functions request multiple parameters, some functions only request one parameter, some functions do not request a parameter at all. This print function here, it requests one parameter, which is a text. So I could add any text here and have this printed in the experts journal of my MetaTrader 5. And then after providing the text, we close the parameter list with a closing round bracket, and we end the line with a semicolon. You end every statement with a semicolon, so the program knows the statement is complete. So what does this do? If I now compile the program and I do have this print statement here, we can go back to the MetaTrader, and now I want you to open the toolbox. If it's not open already, you can go to View, Toolbox, and in the toolbox, I want you to switch to the Experts tab. And here you can see I have a lot of OnInit printed here. So if I right-click and clear this and remove the program from the chart, and if I activate the program again, you will see that if I click on OK, it prints OnInit. And this is really cool, isn't it? And this is because whenever you activate the program in the chart, this specific program's OnInit function will be triggered automatically. What does it mean that it is triggered? It means that the program or MetaTrader pretty much looks inside of the body of this OnInit function and it executes whatever is written here. And if we have this print statement, it will just say OnInit. For example, if I recompile, it will also print this because the recompilation also triggers the OnInit event. And for example, if I switch from the daily time frame to the H4 time frame, the program is also initialized, and you can read it here in the H4 time frame, and it also prints the OnInit here. So we can do the same thing in the OnDinit. Let's just print OnDinit like this. And also make sure to note that I put the text in these quotation marks. Whenever something is in quotation marks, and this is for most of the programming languages, it means that this is a text value. And this will be important later if we talk about data types. So if I compile this in the OnDinit, you will see now if I remove the program from the chart, it will call the OnDinit function. If I activate it again, it will call the OnInit function. If I switch the time frame, it will now call the OnDinit in the H4 first, because this is the time frame where we're coming from, and then the OnInit in the D1. And you can read about this in the Experts Journal. Okay, so this is for OnInit and OnDinit. Now we have a third event handling function here, and this is the OnTick. So if I add this, and if we compile again, we don't have to do anything. We just have to wait for ticks in the chart, because like a tick is just a price movement essentially. So if there's a price movement, and we can just wait for this here, if there's the next price movement, we will see that it will trigger the OnTick. Yeah, you can see there was a price move and it printed the OnTick here. So you can see the OnTick is the one that is where we want to put most of our programming logic, right? Because this is where we can really do the magic and where we can build conditions, etc., etc. So this is what we will do in the following. So yeah. So I think we do not really need this print statement because it's a little bit annoying if we see the information with every single tick. We might keep this one. Also, if we are wondering, how do I understand all of this? First of all, I will tell you in this tutorial. So no worries, you will learn everything you need for this specific program. Also, if you want to learn more about specific functions and read about it, everything is documented in the MQL5 reference, which is maybe the most important tool if you want to become a MetaTrader 5 programmer. So you can move your cursor, your mouse cursor, inside of anything you want to understand. And if it is part of the MQL5 framework, like these functions are, you can go to Help and MQL5 Reference. If you do this, it will open the MQL5 reference, and you also jump automatically to the entry for this specific function or variable or whatever you want to look at. So you can see here what the print message does, and you can see how it looks like. This is the so-called signature, which exists of the return type, the name, and the parameter list. And yeah, you can see, yeah, actually I lied to you. You can add multiple parameters here, but this is a little bit, I don't really want to cover this. It's important for us now that we can print something with this print statement. And you can read everything here. It will explain you exactly how the function works. And this, by the way, also works for the onInit, for example. So if I move my cursor here, and if I click F1 on my keyboard, which is a shortcut, so you don't have to go to Help and MQL5 Reference, it will open the entry for the onInit. So you can see it is called when there's a initialize event. And you can also see, for example, the onDinit and the onTick. So everything's explained in detail. But yeah, this is just for now. So let's go on with the actual programming logic so we get something to work here. But yeah, I'm sorry if I really talk a lot about these absolute basics, but these are really the fundamentals to understand how MetaTrader 5 programming works. If you do not understand how the structure, like this ecosystem MetaTrader 5 works, you will not be able to understand how coding for the MetaTrader 5 works. So this is really, really important. Also, as you can see here, for example, if we go back here to the onTick, you can also see, for example, at the very bottom of the entry in the MQL5 reference, there are some other articles linked. For example, event handling functions. If I click on this, you will see this is an entry in the MQL5 reference that gives us all of the event handling functions. For example, the onStart, the onInit, the onDinit, the onTick, the onTimer, the onTrade, etc., etc. And you might be asking yourself, why don't we see the other event handling functions in our code? This is exactly what was requested here, or what we were asked in the beginning when we created the program. Let me show it to you with an example. You can see these are all of the event handling functions that we could have ticked in the beginning. But I said we don't need them. But if we would have included them, they would be part of our source code. But if you remember, I said we can also add this later on. And this is true because, for example, if I just want to use one of these event handling functions, let's say, for example, I want to use the onTimer function, I can just add it here. And this is exactly the same what would have been done automatically if we would have ticked the box. So you can see everything can also be done later on also. So you can see I can add all of these if I need them. So yeah. But now let's get to the actual coding part. So if we want to write our strategy for now, let's make sure that the first thing we want to do is we want to figure out what the highest point of the last X bars is, right? Because this is the point where we want to enter a position. So here in this chart, I have the Donchian channel indicator activated. But in our program, we don't want to use the Donchian channel indicator. We just want to code the logic for ourselves. So what we have to figure out is we have to figure out what the highest point of the last 20 bars is. So there are multiple ways of doing this. We could, for example, write a loop to loop through all of these bars and find the highest bar. But this is not really necessary because the MetaTrader 5 frameworks, it provides so many predefined functions that you will find a function for almost anything. So for example, if you want to have the highest bar of the last 20 bars, you will find a function for this. So you can get the highest price of the last X bars using the iHighest function. So what does this function do? I will explain it using the MQL5 reference because this is the workflow that you should be that you should get used to if you want to work with MetaTrader 5 and if you want to learn more. Because whenever you read the MQL5 reference, you will understand what the function does. So here it's pretty simple. IHighest, it is the name pretty much of this function. And you can see it belongs to the time series and indicator access functions. But yeah, this is not really important right now. It returns the index of the highest value found on the corresponding chart, shift relative to the current bar. Whoa, hold up. This is a little bit too much, right? Yes, it is. But I will explain everything in a second. Also, next thing, we see the so-called signature of this function. And you can see the return type is int or int or integer. What is this? I will explain this. Now, we have different types in MetaTrader programming. I will write some of the most important data types here. Actually, I think these 4 are the most important. This is also something you will often see. So, we do have different data types, and you can, of course, read about this in the reference. So this is great, isn't it? You can just look up everything. So these are basically most of the important data types. I also added the string and the datetime because they're also important. But you can find, oh yeah, these are not all of them. You can find, is it typecasting? Yeah, you could read a lot about this here, but yeah, let me explain what it does. So you will have this integer data type, for example, which is the return value of the IHighest function. I will get to return values in a second. But integer data type means that this can pretty much be any number like these numbers. These are all examples for integer values. And integer values are always numbers without a decimal point. So these are integer values. Now you might ask yourself, what happens if I need a number with a decimal point? Then it's a double. So these are double values, for example. All of these values are double values because they are numbers with a decimal point. Then we also have Boolean data types, for example. And these can also can only be true or false, or 1 or 0 pretty much. So they only can have 2 values. And then we have the string data type. We used this already because string means texts. These can be any text pretty much. So these are string values because they are text values. And then we have the date time. Date time is, you will see this from time to time in programming. And these are dates and times, as the name says. For example, in the end, it's just a number. And it is the amount of seconds that elapsed since the 1st January of 1970. So this number, 23, would be the 1st January of 1970, 023. Like this would be this specific datetime value. So usually, of course, datetime values are a lot bigger. So for example, I don't know. Maybe it might be something like this, and this might be the 26th May 2024. And this specific time. I don't know. I didn't count the seconds. But just to make you understand, datetime values are under the hood just numbers, but they are interpreted by the MetaTrader 5 compiler as time values, pretty much. And it's always the amount of seconds that passed since the 1st January of 1970. And you will find this concept in many programming languages, by the way. So these are the most important data types. You will find more data types. For example, you might find the long data type, which is pretty much just an integer number or a number without a decimal point, but it can be bigger. So if you need a really big number, it might be a long data type. And you might also see unsigned long or ulong. This is a long value, but it can only be positive. This doesn't work because this is negative and U means unsigned. So it means only positive values. And yeah, this is, for example, this is used in some functions. But just to make you understand that integer and long data types are also always for values without a decimal point. Double values are for values with a decimal point. You might also see short from time to time, which is pretty much the same as double, but the values cannot be as big as double values. And then also you will have a bool, which is either true or false. It's often used for conditions. We will get to this later on. And then we have text values, which is the word for this is string data type, and this is always wrapped in these quotation marks. So these are some important things. But in most cases, you can just use integer data type, double data type, and then you will often see bool, string, and datetime in programming. And if you see a long, you just know it can be an even bigger number. And then, also to answer the question, why is there even a integer and a long data type difference? Like, why is not everything a long data type? This would theoretically work. I think this comes mainly from the past, where computers were limited with their storage. Like random access memory was limited, the hard drive disk space was limited. And in modern times, this is not as important anymore. So in really high-level modern programming languages, you might also see that there's not even a difference between int and long, for example. It's just all the same pretty much, and the compiler takes care of it, and I think it's stored. I don't want to get into detail, but this is mainly coming from data management issues, I think. Because these different data types, for example, if we have a look at the reference again, you can see they take up a different amount of space in your random access memory, in the working memory of your PC. And for example, you can see integer data type, of course, it takes less bytes than the long data type. Because if you have more bytes in your random access memory, you can put more and bigger numbers into this. Because the numbers, you might have learned this already, are stored in the computer memory as binary code. And it starts like this. Like, for example, if we have, I don't know, like this is 1. Like this is 0. This is 1. And then we have, I think this is 2, right? This is 3. This is 4, if I'm not wrong. And 8 bits should be 1 byte. So it looks somehow like this. Don't judge me if I mess up the binary numbers here. I'm not using this a lot because I'm a human, not a computer. But yeah, this is how it works. And now you can see that if, for example, a integer number has this amount of space, I think 4 was 4 bytes, right? 23 bits. So 4 times 8 bits is 4 bytes. So you can see the biggest integer number would be this. Pretty much, right? So this is the biggest integer number, and it should be something like this. Or really close to this. I don't know how exactly the computer interprets this, but it also depends, I think, a bit on the coding language, etc. But yeah, so this is the biggest integer number. But if we now do have a long value, you can simply double this. So you can say we have this much space, these many bits or bytes for a long value. So also the numbers that we can store can be a lot bigger. So this is why we have different data types. And yeah, I'm sorry if I get a little bit too deep into this topic, and if you just want to learn how to write this program. But again, these essentials are so important if you want to become a programmer. Or at least for me, it's really important to understand how the computer thinks and how everything works. So I can really learn how and why I use specific data types, for example. And it's also interesting, I think. So yeah, this is why we have different data types here. And yeah, we will use these data types later on, or some of these, and then maybe we can come back to or maybe let's make this a comment for now, so we can keep this as a little reminder later on. So what does this help us with the iHighest function? We learned that the iHighest function returns an integer value. Now we know integer values or integer numbers are numbers without a decimal point. So the iHighest function could return anything from 0 to 2 billion, whatever the highest integer number was. And since it returns a value, we will store this value in a variable then. Because if we just call the function like this, the value will go just anywhere. But if we say we want to call this function and we store the return value in a variable, like this for example, it will mean that after the function is called and processed, the return value will be stored in this variable. So I will explain how this works in a second. But first of all, let's have a look at the function again. We can see in the signature here, there are 5 parameters requested. So this is, looks confusing, but it is not. And these parameters are requested because the program or the MetaTrader needs to know for what specific symbol, for what specific time frame, for what specific time series, and in what specific section of the chart we want to get the highest value. Because there are so many charts and they all look different, right? So it really makes a difference if we are using the US 30 or the Euro US dollar and what chart time frame we use, right? Let me get rid of this print statements, by the way. And so we have to tell the PC what symbol we want to use. And here we could use a US 30 as the symbol. And you can see in the reference here, you also know what specific data type is requested for this specific parameter. So the first parameter is a string parameter. So string for us means text. So we have to put this in quotation marks, and we can, for example, provide US 30 as a value, which is the name of the chart or the symbol that we want to calculate the value for. Then the second parameter is here. This might be a little bit confusing because it requests a enum timeframes enumeration value. I didn't really cover this yet, but enums are, if we click on this link in the reference, enums are enumerations, which means that there are a set of predefined values. So you can see, for example, this enum timeframes, it can be any of these values. So why did not I explain this when I talked about data types? Because enumerations are not really data types. They are an implementation of data types, or they are like when you use enumerations, you map a value to a specific identifier. And this is mainly used to make it easier for us as a human programmer to work with these enumerations. Because under the hood, all of these IDs are just integer values, basically. So if I can show you, for example, what's going on here, if I print, for example, if I print one of these values here, if I print period M1 or period M5, let me just print this, period M1. And then also I print, and you can print multiple values using these commas, and then just concatenate these values. Period M5 or also period current. What happens if I print this in the onTick function? So we will see this here, and you can see period M1, the value is just 1. Kind of makes sense, right? Period M5 is 5. Period current is 0. So you can see all of these identifiers, they just stand for a specific value. And we could also use these values here. Like for example, if the iHighest function requests a time frame here, as we can see in the reference, We could say, for example, I want the 5-minute time frame, so I just go with 5. This would work. But it's easier for us to write period M5. Because in this case, it's super easy to read as a human programmer. And also, by saying this is a enumeration, it makes sure that the programmer only provides one of the values that are part of this enumeration. So yeah, so this is a little deep dive into enumerations. Then we have the next enumeration here, but whenever you see an enumeration, you can just look it up in the reference. Like the next one is the type, and you can just read about it here. It's the time series that we want to get, and we can also click on this link to see all of the enumeration values. For example, mode open, mode low, mode high, etc., etc. We will use mode high, of course, because we want the highest price. So we go with mode high. Then the next two parameters are of type integer, and this is what we know already. And here we have to say how many candles we want to look back. Let's go with 20. And then we want to have the starting value. Let's go with 1. So if we end the parameter list using the closing round bracket and end the line with a semicolon, we can now compile. So no error, everything's fine. This is how it should look at your PC now. And you can see if I, for example, write 5 instead of period M5, it's still the same. No problem, no issues, but this looks way more readable for us as a human programmer, right? So before we get into the optimization of these values, let's have a look at what we did here. I created a so-called variable. Variables are used to store values. And if we want to store values in the random access memory, remember, it looks a little bit like this. We have a lot of bits and bytes. I don't know, this is this 8? 4, 8? Yeah. So this is, for example, these are 4 bytes, right, in the random access memory. And of course, the random access memory has more than 4 bytes. So the random access memory looks something like this. It has a lot of bytes, right? Many bytes, many bytes, many bytes. So many gigabytes actually. So this is the storage of your PC. And every program, or most programs, will use the storage of your PC. So I don't know, for example, this part of the random access memory, it might be blocked already by another program. Some program is using this. Some program is using this. Some program is using this. And it is called random access memory because the memory is allocated randomly pretty much. And this is a method that is really fast. And it means that it's pretty much, yeah, everywhere in the random access memory can be some values. And if we go ahead and now declare another variable in our program here, this variable will have one space reserved in the random access memory. So for example, if the program sees we will need this highest variable, which is of type integer, the program will then know that the integer data type, it takes 4 bytes, so it will go ahead and reserve 4 bytes somewhere. So it will say, for example, reserved for highest variable. And it will reserve these 4 bytes here in the random access memory. And this highest variable, or the name that we gave this variable here, it is pretty much just a pointer to this specific space in the random access memory. So this is how the computer works. When you declare a variable, it will reserve a spot in the random access memory of your PC, and the name of the variable is the address pretty much of this specific spot in the memory of your PC. So for example, if we now store a value in this specific variable, for example, the return value of the highest function, and let's say the value is 13, then the program would go ahead and it would see that the 13 is stored in this highest variable. So it would go in the random access memory. it would know the position because this is a pointer to this position. And in this block, it would know store 13. And I don't know, it might look something like this. This might be 13 in binary code. I don't know, look it up. But no, at this specific position, there is 13 stored. So what happens if we now go ahead and print this variable? If we print this variable, it means that we do not print highest, because this is not a text. This would be a text if we would put it in quotation marks, right? In this case, it would print the word highest. But since it is not in quotation marks, the program assumes that this is a variable. And it is a variable, of course. So in this case, it will see, okay, we want to print the highest variable. But of course, we do not print highest as text, but the program now goes into the random access memory. It will search at this specific location because, as we learned, highest is just a pointer to an address in the random access memory. And here, we will find this highest variable at this specific point. So it will read this information here, and it means 13. So we will print 13. So let's compile this, and let's see if we print 13. Oh yeah, of course, this is not really, it's not code, so we cannot compile like this. But if I comment this out, it will work. So we print with the next tick. We should print the return value of the iHighest function. And it is 2. Okay, it's not 13, but it is 2. So it means that in the M5 time frame, in the last 20 bars, the highest time frame is at index 2. So let's go to the M5 time frame. And we can see that if we go back here, like from the current bar, we go 2 bars back. It is the highest of the last 20 bars. And what does this 2 means? It is an index, a shift value in the chart. In every chart, or in programming, we use this concept of bar indexing. Because we work a lot with prices and bars, we need a method to learn what specific bar is at what specific index. So you saw it just created a new bar, and now the value is 3. Because the bars all shifted 1 to the left side. And it is always counted like this. The current bar is index 0. The previous bar is index 1. This bar is index 2. This bar, the highest bar, is index 3. This is 4, 5, 6, 7, 8, 9, 10, blah, 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 blah. So you can see whenever there's a new bar that appears in the chart, it will automatically become index 0. The bar at the left is index 1. The bar at the left of this one is index 2, etc., etc. So we just count the bars from the right side pretty much. So yeah, this is how we can work with variables. So we can store values in variables. We can access values in variables using the variable name. And we can also change values in variables like this. For example, if I put here this would mean that the value 3 is put into the highest variable, but then I change the value like this. And if I compile again, now you can see we're printing 13 because we can only store one value in this variable at a time. So yeah, this is how it works if we want to use variables. Also, we can use different variables. We can use a double variable. And here we could store double values. We could use a Boolean variable. And we could say this is true or this is false. And now again, you start to understand why we use these different data types. Because all of these 3 variables take up different space in the random access memory. This is 4 bytes. This is 8 bytes. This is 1 byte. So you can see by saying what specific data type it is, the program is able to, first of all, reserve the needed space. And then also, if we read this variable, it's also important to know the size. Because if we read, for example, a integer variable, this address will point to the first byte or bit of the variable. And then if we know it's an integer variable, the program knows we have to read 4 bytes. But if we read a double variable, it knows we have to read 8 bytes. But if it's a Boolean variable, we just read 1 byte. So this is why data types are important and how everything works with the variables. So now we learned what a variable is and how it works. I didn't really explain why the iHighest function is doing what it does now, right? So let me explain this. iHighest function, it is a predefined function. We don't really know 100% how this function looks, but we don't have to, because it is explained here. So we can just assume that the iHighest function will return the index of the highest bar or of the highest price in the last X bars. So what did we do? We said we want to have this in the US30. We want to have this in the M5 time frame. And I can also change this to D1, for example. Then we say we want all of the high prices of the last X bars. The last X bars are in this case 20, because we added 20 here. And then we want to start at index 1. So if I compile this again, you can see if I go to the daily chart, what does this mean? It means that we start at index 1 and we go 20 candles back. So we learned about the indexing thing. So index 1 is this candle, because this is index 0. This is 1. So from this candle on, we go 20 candles back. So, or we count 20 candles. The first one is the first one. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, blah, 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 until we hit 20 bars, somewhere here. And out of these 20 bars, it will give us the highest of all of the high prices of these bars. And it should be index 0, 1, 2, 3, 4. It should be index 5. So with the next tick, that will hopefully come here in the next few seconds, we will see, or we should see, that it prints 5. Yeah, so I now have to wait for the next tick, which is not really coming here. And there was a tick. Why don't we print this? Oh, because I deleted the print statement, right? So if I compile it like this again, you can see it should print the value 5, and it does. Because as I just explained, from the first value on, we will check the last 20 bars, and we will get the highest out of the high prices of all of these bars. And then it returns the index or shift value. So this is still not the high price, right? But now we can use this to get the high price. And the price is a double value, of course, because as you can see here, prices do have a decimal point usually. So we want to store it in a double variable. So we would say high, and we say iHigh, and this is another function. You can read about this. It will return the high price of a bar at a specific index or shift parameter. And this is great because we do have this shift parameter. So what we provide here is the symbol again, US30, the time frame, period D1, and then the shift value. And here we will just use the highest variable because it is the value 5 or whatever value is the highest or has the highest price. So if I compile it like this, you can see now we get the shift value and we also get the price of this bar here. And yeah, you can see this is in fact what is printed here. If you want to have the exact price, you can look it up in the data window. Press Ctrl D and you can see here this price is exactly the price that is printed in the journal here and which is written here as the high price for this bar. So you can see our code is working just fine. Yeah, let me delete this. But there are some things we could optimize here already, because here we hard-coded the symbol, which is not really good. I would never do this if I write a program, because if you, for example, activate the Donkin channel program in another chart, let's say the German index, if I would activate it here in this chart, it would still calculate the value for the US30 because it is hard-coded. So this is why instead of hard-coding, we want to use a variable for this. And the variable we want to use is underscore symbol. So what does this do? If we have a look at the reference again, and yeah, this is what you can always do if you want to learn something. You can see this is a string type variable. It's a predefined variable, and it always contains the symbol name of the current chart. So if we print underscore symbol, you will see it will print exactly the name of our symbol here. So for example, in this specific chart, it will print US30, but if I activate it in the DE40, you can see in the DE40, it will print DE40 instead. As soon as we see a tick here, in the DE40, you will see that it will print DE40 in this chart. I don't want to wait for the tick. You can do it on your own PC, but yeah, just print it DE40. So you can see it always uses the current chart, which is great. Then also the period is hard-coded here and all of the other parameters. And this is also not really recommended, I would say. Instead, we want to give the user of the program the chance to change these values. And the user can change these values if we use, instead of these hard-coded values, we use variables. For example, we can say, instead of using period D1, we can say we create a variable which we name time frame, and we say, I don't know, period D1. If we compile this, we can now use the time frame here. But since this is a enumeration, it does not really work like this, but we can also declare a variable of type enum timeframes. So we can use the exact enumeration type or enumeration here that is requested as the data type pretty much for this variable. Under the hood, it's still pretty much just an integer value, but it helps us to use this variable here as a parameter for this function. So we can now use it here and also here. Then we do have mode high here. And this is what I would keep as it is. But then there's this, the count, and I want to change this. I want to make this a variable. Int. So I just write count, and I just write 20, for example. And yeah, shift value will be hard-coded with 1 because it doesn't really make sense to change this. But here I can now say count instead of 20. So what does this mean? This means that whenever these values here are changed, also the function here will calculate a different value because it will use these variables, right? So you might ask yourself, what's the difference? There is no real difference because the user of the program would have to go inside of the source code here to change these values. But there's a trick how we can make these variables so-called input variables. So let me take these two variables, let me cut them here, and let's move them to the very top of our program outside of any function. This is important. This cannot be inside of any of these event handling functions. You have to put it outside of the functions on the so-called global level of the program. Because whatever is written here on the global scale or global level of the program can be used in any of these functions. This is not the case for these local variables, because if I want to change the highest variable here, for example, in the onDinit, it does not work. But if I want to change it here, it works. Because here in this onTick function, this variable is declared and it is well known here in this onTick function. But in the onDinit function, the program simply does not know about this specific variable, so we cannot change it here. So this is a matter of scope. And the functions all have a different scope. And functions that you declare outside of any function or on the global scope or scale, I don't know what the word is, they can be used everywhere in the program. So I can change the count here. I can also change the count here. No problems at all. Because I declared the variable the global scope here. And then, this concept is important because it makes your program way more structured. You might be wondering why we do not just declare everything on a global scope. This will work for small programs, but for complex programs, it's not recommended at all because it's super confusing. But what I want to do here is, this doesn't really change a thing because the user would still have to go inside of the source code and change these parameters, right? But we want the user to change it here in the program, in the MetaTrader. So to achieve this, we can simply make these variables input variables. We just add this input modifier before we declare the variables. And if we compile this again, now you can see these variables can be changed here in the inputs tab of your program. So if you double click on the program here, or when you activate the program, the user is able to change these values. And yeah, you could change these values. And after changing these values, the variables here are updated. And now the current values that the user chose are used. So this is really, really cool. Also, you can see these were now color-coded in a different color because they are input variables. And I like to make the first letter of my input variables a capital letter, so I know later on that these are input variables. Also, you realized once I made these letters capital letters, I get some errors because MQL5 as a programming language is case sensitive, which means that this is a different variable if I change the first letter to a capital letter. But if I now change these also to capital letters, it works again. So you can see the user is now able to change the program without having to look inside of the code because these are now input variables. Okay, so now that we have the high of the last X bars, we now have to figure out the moment when the current price reaches above this specific high, right? So we have multiple options here, and I will show you one or two of these. So the first thing we can do is create another variable, which I will call just bit, and I will put the value, the return value of the symbol info double function into this new bit variable. The variable is named bit, the type is double, so it's a value with a decimal point. And I will put, let me finish this quickly, and then I will explain what the symbol info double function does. It is a system variable, as we can see by the violet color of the name of the variable, and we can also find it in the MQL5 reference. And it will give us a specific property for one specific symbol. So this explanation is very unspecific, so let me get more, more specific. We do have two parameters, and with these two parameters we will have to define first for what specific symbol we want to get this property, and secondly, what specific symbol we want to get. So first thing is the symbol, and I will use underscore symbol. Again, little reminder, you could also do this, but this is hard-coded and it will always work for US30, but if you use this, it will always work for the current chart where you run the program in. Then we will have the identifier, which is the second parameter. And in the documentation here, you can also click on the link here for the enum symbol info double. And here you will find all the possible identifiers with the description and the type. So type is usually always double because we use the symbol info double function, so it makes sense. And by this point, you might also realize or imagined already that there is also a symbol info integer and also a symbol info string function. So you can read about them also if you're interested. But for this function, we will get all of the double values. For example, the current bid price or the current ask price or the point value. So there are some of these identifiers that I personally use frequently in my programming. If you are interested in all the properties you can get from the symbol, just make sure to read about this enumeration in the documentation. So this will give us the bit price. And now we do have the bit price and the high price. And what we want to check is at which moment the bit price jumps above the high price. And always keep in the back of your mind, all of this is done in the onTick function. So with every single tick, we do this calculation and we do this calculation, or we update the bit price, or we get the latest bit price. So when there's a tick, the bit price usually changes, right? So with every single call of this onTick function, at every tick, we will have a different value for the bit variable. This means that at some point the bit variable might have or hold a higher value than this high variable. So what we do here is we check if bit is higher than high. This is what we want to check, and we do have this comparison operator. There are multiple operators like this in programming. For example, yeah, we do have this. This is greater. This is smaller. So you're just comparing values. It's really easy. This is greater equals. So it's greater or equals. This is smaller or equals. And then we do have this, which is used if you compare two values that are equal. And this can be used if you compare two values and they should not be equal. So you can use all of these comparison operators to compare two values. Like for example, this comparison, it would be true if bit is greater, like the bit price, for example, the bit price is this and it's greater than this. This is high currently. So in this case, it would be true. But it would be false if the bit price is smaller than the high price. So if bit is greater than high, it's true. But if bit is smaller than high, this would be false. I mean, this is pretty obvious, I think. The other way around, if it would be like this, if this comparison would look like this, it would be false here and true here. So we're just comparing two values. Really simple. Then, of course, if we would have something like this, then it would be true also if bit and high have the same price, right? And also, if it's like this, it would also be true if they have the same price. And it would be like this. This would be true because the values are not equal, right? So this is how you can use comparison operators. So if we make a comparison like this, you realize that I used true and false a lot. And if we remember, we had to look at the Boolean data type before, which only holds the value true or false, which means that we can create a Boolean variable for this, which looks like this. So we can store the result of this comparison in a Boolean variable, because this comparison, it can only be true or false. If you compare two values, one of them is either higher than the other, which would mean this is true, or they are equal, or the first one is smaller, which would mean this is false, right? So this is how you can use Boolean variables. And now, since this is true or false, this signal variable, we can also check the value that is inside of this signal variable. And we can do so using a so-called if statement. A if statement is a control structure. A control structure is used to control your code, because if you would never use control structures, everything would be processed linearly, I don't know how to say. Everything would be processed from top to bottom, and you would have no control over your code. But with control structures, that's where the name's coming from, you can control your code, because sometimes you might have a block of code that you do not want to execute with every single tick. For example, the opening of a position. We do not want to open a position with every single tick. This would lead to complete chaos. So what we have to check if we do have a signal. And for this reason, we can use if statements. If statements look like this. You have this code word, if, then in round brackets, you have a condition, and then in curly brackets, you have a body. What does this mean? It means that once the code reaches this line, it will see, oh, hey, there's an if statement. Let me check the condition. So next thing that's done is the condition is checked. Conditions can be true or false. So it will check if this condition is true or false. And in our specific example, we do have the signal variable as the condition. And this is enough as a condition because it can be either true or false. That's what I explained before. So this is our condition. So if the signal is true, we will enter the body of this if statement. This is the body. If the signal is false, we will not enter the body and we will proceed with the rest of the code. So this is how a if statement as a control structure helps you to control and structure your code. So what we want to do here is, if we do have this signal, and by the way, we can do it like this, and I said I want to show you another way, we can also do it like this. This would be completely the same outcome. So we can build the condition or do the comparison directly inside of these round brackets of the if statement, or we can do it before and store the result, for example, in a Boolean variable and use this Boolean variable as a condition for the if statement. Both ways are totally fine. Mostly in programming you will see it like this, I think, because it just saves one line of code and it's still super readable. So yeah, this is how we can check our condition. And now in the body, this is the part again that is executed if the condition is true. Here we now want to open a position, right? And in MetaTrader 5 programming, there are two ways to open a position pretty much. One way is confusing and complex. So we will use the second way, which is super easy and yeah, you will immediately understand it. So for the second way, we will make use of a class. This class is already part of our MetaTrader or MetaEditor or whatever you want to say, because we can find it in the navigator. On the left side, you do have the navigator, and if you scroll down a bit, you should find this include folder. If you open this folder, you should find the trade subfolder. And if you open this folder, you should find the trade.mqh file. You can double click this and this will open a file which is really big and honestly also a bit confusing. But the good thing is at this point you don't have to understand this. I will not cover this in detail in this tutorial. If you really want to understand this, and I explain everything as I do in this video, like really carefully, really slowly, so I make sure that you understand it. So if you really want to understand everything about classes and so on, check out the links below this video. I linked the MetaTrader 5 Masterclass and you will learn everything you need to know. But for this short tutorial, it is just important that in this specific file, there is a lot of code that is written already. And we can use this code without having to write these 1000 lines on our own. So what this code here does is, in a nutshell, it helps us to open, close, manage positions, orders, and deals pretty much. So let's close this include folder again. This is just to show you what we are doing, but in our actual code, we don't need to write these 1000 lines. We just need to write one single line. And it looks like this. You just write this hashtag include, and then I call this spiky brackets, but in fact it's just a smaller than and greater than sign. And between these spiky brackets, you write trade/trade.mqh. And this is just the path to this specific file starting in the include folder. So trade subfolder, and then the file is named trade.mqh. So this is where this line is coming from and why we use it. And this include means that we now want to include all of the code that is inside of this file, which means we now have access to all of these 1000 whatever lines without having to write them, and honestly also without having to understand everything that is in this file. Because all we have to understand is that we can now use this ctrade class, which is defined in this specific file, and we can work with it. So for this tutorial, it is just important for you to understand that we can now use this ctrade class as a data type, so to say. I mean, like under the hood, it's a little bit more complex because this is a so-called class that is defined in this file. But for this video, you can see this as a data type pretty much, or a class type. And then this is just the creation of a variable. But this variable does not have a simple data type like integer, double, or bool, but instead the type, this variable is of type ctrade, so to say. So what does this mean now? We can now use this variable, and this is where everything starts to make sense, to open, close, manage orders, deals, and positions. So what we want to do is, we want to use this trade, and this is now an object variable, so you heard this term also, and we can say trade dot, this is a, I think it's really called a dot operator or something, or point operator, and then we say, or you can see there are a lot of previews for functions that we can now use. So you can see it's super powerful that we now have access to this ctrade class, because all of these functions are defined in this 1000 something line file, and we can use it right away with just this include line. So what we want to do is we want to say buy, trade.buy. And here you can see there is a list of parameters that is requested. It's really easy to understand. This will open a buy position, and we have to say how many lots we want to buy. For example, we can go with 1.0, but what I would recommend is say lots and then make this a input variable. So at the very top of our program, we could say input double lots, and then we say 0.1, for example. So it's an input variable, which we can see with this input modifier. It's of type double, so we do have values that can have a decimal point, and the name of the variable is lots. The basic or standard value is 0.1, and the user is able to change this because it's an input variable, right? So then, after providing the lots, we now have to say what symbol we want to buy, like what market, what currency pair, whatever, and we will use underscore symbol again, as we used before multiple times. Then we can say what price we want to open, what stop loss value we want to have, what TP value we want to have. So you can see this buy function here, it helps us to create a fully working position with the opening price, stop loss, and take profit. And we can also have a position comment, so we know where this position is coming from. I will not fill these parameters, and at this point I do not have to, because you can see here in the signature of the function, which is highlighted when we start adding the parameters, you can see there is, for example, for price, it says price equals 0.000, and then we have SL equals 0.000, TP equals 0, and symbol comment equals null. So you can see we have this equals for every value. And this means if you see this in the signature of a function, it means that there are predefined values. So if we do not provide these values, it will use the preset values. So I can just stop providing more parameters like this, and it will use all of these default values like 0, 0, 0, and null. And this means it will open at the current price without stop loss, without TP, without comment. But for this purpose right now, this is fine. Because if we compile this, I want to show you that even with these just like 30 lines of code, I mean, this is barely any code, right? Most of this is just a blank space. So with these lines of code, we can already open positions. So now after compiling, I want you to go back to your MetaTrader 5 and I want you to go to View. You can close the toolbox and then go to View and open the strategy tester here. And then in the strategy tester, you can click on Visualize. Then for Expert, you select the program that you just created. For me, it's Donkin Channel YT. You can choose a symbol you want to test on. Yeah, I will just go with US 30 to stick to this example I used before. You can select a time frame you want to test on. I will go with a daily chart, a time period. I will just test for, let's say, the last year. And then that's pretty much it. I would suggest that you use every tick based on real tick because it's the best method to like let you understand what it does. And then you can also go to the next window, or wait, first make sure that this is ticked so you have the visual mode enabled. Then you go to the next tab and you can see these are the inputs that we defined, so the input variables. So we could change them here. But yeah, for this test, we will just leave it as it is. And in the lower right corner, you can click on this little start button. It should be green. And then it will open another separate window with the simulation of this specific expert advisor in the symbol you want to test and in the time period you want to test it, in the time frame you want to test it. So this is a super powerful tool for testing your strategy to see if it works technically. This is what we do right now. And then also after creating a technically working strategy, you can use this tool to test it. So you can see if this would have worked in the last, let's say, 5 or 10 years. So this will give you more confidence into your strategy, right? Okay, so let me fast forward this a bit so we can see if we open a position and yeah, there we do have a position. Yeah, my program is lagging a bit, so let's wait until it catches up here. And there's a buy position. So let's check if this buy position is correct. And we can do so by saying we want to check if this is the highest bar out of the last 20 bars. So if we go 20 bars back, 20, I think we will go until here. And we can see this is the highest point of the last 20 bars and the price was above this point. And here, this is one major problem. You can see we open more and more and more and more positions. And this is a problem we definitely have to take care of. Because once we hit this trigger level here, where the bid price is above the highest point of the last 20 bars, and the bid price goes up even more, this condition in our code is always true with every tick. And this is one big problem because we don't want to have unlimited positions once we hit the trigger level, right? So what we want to do here is we want to make sure that this only happens once. So there are multiple ways to do so. We could say we want to open a position only if we did not open a position before, if we do not have any positions in the account, etc., etc. What I want to do here is maybe we can, yeah, I will introduce you to a for loop. So what we want to do is we can use a for loop to loop through all the positions. So let's say I will create this for loop for you and then I will explain it. So for loops usually look like this. So you can see it is a little bit similar to the if statement because it also has a keyword, which is for, which tells the PC that there's a for loop coming. Then we have something in round brackets, and then we have a body in curly brackets. And if something looks like this, it usually means it is a control structure. And the for loop is also a control structure that helps us to control our code. So the body is pretty easy to understand because we know this already. This is executed if some kind of condition is true. So let's have a look at these round brackets here. In the round brackets, we have a first part before the first semicolon, which is the initialization of the for loop. So when the code reaches line 29, the program will see that there is a for loop. Then it will find this initialization before the first semicolon here. And this is executed once when this for loop is initialized. So when we reach this line, it will execute this code. And here we create a new variable, which is called I. It's of type integer, and it has the value positions total -1. So what is positions total? It is a system function. It does exactly what the name says. It gives us the number of open positions, which is an integer value. So we get the number of open positions. Let's say we do have one position. And it has this ticket number, for example. This is one position that we currently have open. So these are our positions. So in this case, positions total would give us the value 1 because we have one position, right? So then we subtract 1 from positions total, which would mean we would store 0 in the I variable. What happens if we have multiple positions? Let's say we do also have a position with this ticket number. Now we have 2 positions, which means positions total is now 2. 2 minus 1 is 1. So in this case, we would store 1 in this I variable. So just remember this later on. So we just create a variable, we store the total amounts of position minus 1 inside of this variable. Then the next thing is, after the first semicolon and before the second semicolon, this is the main condition of the for loop. This is checked next. So after the initialization, which is processed only once at the beginning of the for loop, then we check the condition. So here we check if the value inside of this I variable is greater or equal 0. So let's get back to our example. If it would look like this, with only one position, I would be 0, because 1 minus 1 is 0. And then this condition would be true, right? Because 0 is greater or equal 0. So it would be true. If we do have 2 positions, it would also be true, because I would be 1 in this case, and 1 is also greater or equal 0. So yeah, so whenever this condition is true, we then enter the body of the for loop. Body is executed if main condition is true. And after whatever is written here is processed, in the round brackets. So after the body is processed, then we will skip to the last part after the last semicolon here. And then we will process whatever is written here. And this I minus minus means that I is subtracted or lowered by 1. So this here is the same as I minus minus. So we just update the variable I and we subtract 1 from the current value of I. So it means after every execution of the body of a for loop, in this case, we will subtract 1 from this value I, which means that I will become smaller and smaller and smaller. And I is never, like this is only executed once, which means that we start with some value for this I variable, then we check the condition, and then we lower the value in this I variable. And then we do not execute this again, but we check the condition again. So this is a little bit confusing, I know. Let's get our example going here. So if we do have 2 positions, positions. We have 2 positions. In this example, I would have the value 1, right? Because 2 positions total is 2, minus 1 is 1. So I is equals 1. In this case, we see our main condition is true. Main condition is true and body is executed. So then the body here is executed. After this, I is lowered by the value 1. I is lowered by 1. This is what we do here. That's it for the first iteration of the loop. Then, since we lowered I by 1, I is now 0, which means main condition is true because I is greater or equal to 0. Then we enter the body again, which means body is executed again. Then I is lowered by 1 again, which means I is now minus 1, which means main condition is false and body is not executed. And for loop terminates or is over. I don't know, it's processed, whatever you want to call it. So you can see this is why we have a loop, because if we now add another position, let's say we do have 3 positions in our account, positions total would be 3, 3 minus 1 is 2. So in this case, we would have 1 more iteration for our loop, which would mean we would have the iteration for I value 2, I value 1, and I value 0. And then at minus 1, the condition is no longer true, and we leave the loop. So this is how you can use for loops. And for loops always look like this. They have this keyword for. Then in the round brackets, they have the initialization before the first semicolon. After the first semicolon and before the second semicolon, you have the main condition, which is checked before every execution of the body. And then there we have the, I don't know, I think it's called, I don't know how it's called. It's just the part of code which is executed after every execution of the body of the for loop, which means that you always have to build this line so at some point the condition will be false, because otherwise you have an infinite loop and it will make your program crash. But typically you will see something like this, and you will see this loop very often in programs for MetaTrader programs, because you can loop through all the positions. So at this point you might ask yourself, why do we do this? And this is a good question, because right now we are just executing nothing for multiple times, because there is nothing in the body of a for loop. But of course we want to have something that makes sense in our for loop, right? So yeah, let's keep the example here for a while. So what we have to do is we have to add some logical code here in our body of the for loop. So what we want to do is we want to get the position ticket for every single position. Let's say, for example, we have these 3 positions. We have to get the position ticket for all of them. And we can do so by using the position get ticket function. And you can see this function requests a position index. And the position index we want to provide is I. Why do we do this? Because in the MetaTrader 5, every position always has an index, just as every bar has an index. And I explained this before. For bars, the last bar always has index 0. The previous bar has index 1. The previous bar has index 2, etc., etc. And same applies to positions pretty much. So the first position is index 0. Second position is index 1. Third position is index 2. So you can see, if you have less positions, you just have less indices. If you have more positions, you will have more indices. Like the next position would be index 3, for example. And if we do have 3 positions in our loop, we would also have another iteration. Or if we have 4 positions like this, because then I would be 3 in the beginning. So you can see this is why this mechanism totally makes sense. So using the position get ticket function here now, we can have a quick look at the reference. This will give us the position ticket of a position at a specific index. And now we learned about the indexing, so we see that, for example, if we have 4 positions, the index go from 0 to 3. And if you paid attention before, you will see these are exactly the values that are stored in the integer variable I. So we can use the variable I for all of these indices to get the position ticket. Also, this position get ticket variable will be of type, or return a value of type unsigned long. So position tickets in MetaTrader programming are usually long values, but don't be confused, it's just a integer variable in big. So we will use unsigned long. And this U just means it's always positive. This makes sense because ticket numbers are always positive in MetaTrader programming. So now for every execution of the body of this for loop, we will get a position ticket of the position at index I. And this value will always be different in every execution of the body because I is always different and there's a different position at index I. So now since we have this position get ticket variable executed, this will already automatically select a position. You can also select it again, position select by ticket. I do this sometimes because it makes the code a little bit more readable for me. I don't know if it's just me. So you could add this line of code, but actually in this case you don't really have to. So yeah, maybe let's just not do it this time. So once we get the position ticket number and use the position get ticket function to do so, you can see in the reference, this will automatically select the position to work with using functions position get double, position get integer, and position get string. And I will explain this in detail because this is super, super, super important and one of the most important concepts if you want to work with a MetaTrader and MetaTrader programming. Because after selecting a position, we can use these 3 functions to get the properties for this position. So let's have a look at, for example, the position get integer function. You can see the position get integer function, it will return an integer value for the currently selected position. And you will also see it requests one parameter at least, which is the property ID. So if we have a look at this enumeration here, where this is explained, we can see these are all the identifiers. And there's a detailed description, so read this if you are interested. So for example, we can check the position ticket, the position opening time, the position magic number, the position type, and so on and so on. So how does this look? Actually, the first thing I want to do is not check a position integer value, but a position string value. So we will check the position symbol, and we can do so using position get string, because this is a string value, and we want to store it in a string variable. So here we do have 3 options. We can use position comment, external ID, and symbol. I want to use symbol, which means that this function will return the position symbol of the currently selected position, which could be US 30, for example, or could be DE 40, or could be Euro US dollar. It depends on the position that is currently selected. And this is why you do have to select a position before using position get string, position get integer, and position get double. You can select a position using the position get ticket variable, or also position select or position select by ticket function. So now that we have the position symbol of the currently selected position, we want to check if condition, if position symbol is equals or chart symbol. Or actually, we want to check if it is not equals or chart symbol. Because in this case, we want to continue. Okay, this is going fast, I know. But what we do here is we just use a if statement. We have the condition. So we check if this currently selected position has the same symbol as our chart symbol, because we know our expert advisor should only work with the chart symbol. And if this is not the same, comparison operator, we want to continue. This here is the body of the if statement. We learned before that the body is always wrapped in round brackets, right? So this would work like this. But if I remove the round brackets, it also works. And you can do this if the body of a if statement only has one line or one operation or one task or one statement. So if you only have one specific thing that is done in the body of an if statement, you don't necessarily need the curly brackets. But you can also add them. It's up to you pretty much. So what does this continue do? The continue operator is pretty easily explained. It will skip everything that is following in the body of the for loop, and it will automatically proceed with the next iteration of the loop. So if we see that this continue, or if this continue is executed, everything is written here is skipped if continue is triggered. And then we will proceed with the next value, we will proceed with decreasing the I value by 1 and checking the condition again. So this is a way of making sure that this for loop only, like everything here is only executed if we found a position of the same symbol as our expert advisor should work with. But there could be still positions in the same symbol that our expert advisor should not manage because they were opened manually or by another expert advisor. For this reason, we can also check the magic number of the position. And we will get this by using position get integer and the identifier position magic. And then we can check if position magic is unequal a magic value, and then we also want to continue. Okay, now you might be asking yourself if I want to make fun of you, because in the beginning, or I usually say that programming is not magic, and it's easy, and everyone can learn it. And now I'm talking about magic suddenly. But no worries, I will explain what this is about. So I will explain the concept of the magic number in MetaTrader 5 programming. So in MetaTrader 5, every position can have a magic number, or actually every position has a magic number. And if you open a position manually by clicking buy or sell in the MetaTrader, the magic number is 0. But if you open a position programmatically using an expert advisor, you can change this magic number. And I want to create this input variable with the name magic up here. So I want to say input int magic. So I want the user to decide what magic number he wants to use for the positions of this EA. And this can be any number pretty much. So it could be this, could be this, could be this, could be this. It does not really matter. Because all you have to understand is this magic number should be unique for your expert advisor. So every position that this EA opened has this magic number. So later on in our code, we can check the magic number of our positions in the account and compare it to the magic number of this EA. So this will make sure that we only manage the positions that have the same magic number. So little trick, but very, very helpful to not mess up everything. So right now, this magic number, I mean, we declared it, it is here, but our positions are not open with this magic number. But to make sure that this happened, we can say trade set expert magic number. And then we set this magic number, which means that for this trade object here, every position is now opened with this specific magic number. So later on, if we loop through the positions, we can find the positions using this. Here it says possible loss of data because position get integer. It returns a long value, so you can fix this saying this is a long variable. You can also fix this. Yeah, let's do it like this. I think position magic, yeah, it's a long value. So let's make the input variable a long variable. So then we don't see this warning. Okay, so if we selected a position and if it passed both of these two checks, then we know that this is a position of our expert advisor. And in this case, what we can do is we can say, here we create a Boolean variable which we name is position open, for example. And if we loop through the positions and we find a position that passes both of these two lines, then we simply say is position open is true. So only if we have an open position, this value will be set to true. And then before opening more positions, we can check if not position is position open. So only if position is open is false, we want to open positions. Also, what did I do here is I combined two conditions. So this is the first condition. Oh, by the way, saying exclamation mark and then variable name is the same as saying is position open is equals to false. This is the same. It's just a shorter form. So here we are checking two conditions, and we can combine multiple conditions using a, I don't know what it's called. It's not a comparison operator. It's a combination operator. No, I think it's a logical operator. That's the correct term, I think. And we have multiple of these logical operators. We have this and, we have this or, we have this, yeah, I think that's pretty much it, isn't it? Yeah, I don't know. So we have and or. I think there might be more, but these are the most important. So we can say if there are two conditions and they are combined using this and operator, it's two of these signs. This is important. Only one is not really sufficient. If we see this, it means this if statement is only true if both conditions are true. So only if we do not have any open positions and if the bid price is higher than this calculated high price, then this overall condition is true. It would be different if this would be a or. In this case, it would be enough if only one is true. But this doesn't make sense in our case, so we use this and. So if we compile again, and if we now go to the programming, the MetaTrader 5 tester again, and do the same backtest with this program, but with the updated code, you will now quickly see that the code is pretty much the same, but we only open one position and no more, as long as this one position is not closed. So this is super, super important. In any program, you should make sure that you do not open infinite positions, which will completely mess up your account. So it's always important to add some logic like this. But if you add a logic like this, and this logic is, there are no errors, this is completely safe. So don't worry about using automated programs. If your code is fine and if you made sure that you checked everything correctly, there is no room for error. No worries. The program will not blow your account. It is safe if your code is correct. So yeah, let's go to the tester here. And now you can see even if the price reaches above this high of the last 20 bars, multiple times, we will only see this one position, because as long as it is not closed, this condition here cannot be true again, because is position open is now true if we have an open position and we find it because it has the symbol and the magic number of our expert advisor. So now that we learned how to open positions, we have to learn how to close them. And we could close them manually, and this is actually very easily done because we can just do it using the trade class here, object variable that we have. But we can also do it like passively with TPs and stop losses, and this is what I want to add now. So at the beginning, let's create some more inputs, and let's say, for example, we want to create an input for the take profit in percent and the stop loss in percent. Let's choose some default values, and after creating these two input variables of type double, we will now calculate the TP and the stop loss before we open positions. And if you remember, we do have the option to provide more parameters for our buy function here, and we can add the price, the stop loss, the TP, and also a comment. And what we want to do is we want to provide the open price. We want to provide TP and SL. So what we can do here is, first of all, we can calculate the ask price, because this will be our open price for buy positions, of course. So just use symbol info double underscore symbol ask. So nothing really to explain here. It is completely the same that we did here before for the bid price. We just changed the identifier here for the second parameter. Then we want to calculate the take profit, and I will create another variable for this. And here we want to calculate the TP. So for a buy position, the TP of course has to be above the open price. So we can use a calculation which looks like this. Ask plus, and then we want to say ask multiplied with the TP percent divided by 100. So we will add a specific amount in percent of the current ask price on top of this ask price. And we will do the same thing for the stop loss, but in this case, of course, we will subtract the stop loss percent. So it will look like this. And now we can say we want to use this ask price here as the open price, the stop loss and the TP variables as stop loss and TP. And if we compile this, we can now go back to our testing environment, start another backtest, and we will quickly see that now our position has a TP and a stop loss, which is super, super great, because now the positions will also be closed if hit the TP or stop loss. So let's wait. Yeah, first position is here. You can see we do have a TP and a SL. TP is 2%, SL is 1%. Here with the stop loss. And now we can see we will open multiple positions now because, yeah, of these TP and stop loss levels that we place. And there's one problem if we hit the TP, because it means if we hit the TP, it means in 99% of all cases, or 100 if I'm not wrong, that we also made a new high, which means that after hitting the TP, we immediately open in a new position, which is probably not really what we want, right? So we would have to add some more code for this, I would say, because otherwise, yeah, after hitting the TP, we will just open a new position. So I think the easiest and maybe most logical fix here would be to not use a TP or make this TP at least optional. So how we can do this is we can say, for example, TP by default is 0, and only if TP percent is greater than 0, then we want to update the TP value and use an actual TP. Because if we use TP 0, it means there is no TP set for this specific position. So doing it like this makes sure that there is only a TP placed if TP percent is greater than 0. And again, make sure we use a if statement here. We don't need the curly brackets because there's only one statement following. So if we make the TP percent maybe 0, in the inputs, and yeah, if we do another test, you will see there is no TP placed. I mean, this is pretty easy to understand. Not sure if I have to show you this, but also in this case, we have to make sure that we do close the positions at some point. So we should enable a trailing stop loss, and we could, for example, say we want to create a variable for this, a input variable of type bool. And Boolean variables can only be true or false, which is really cool because then you get this, didn't compile. Then you get this little, there it is, this little drop-down menu where you can choose between true or false. And now, since we have this input, we can make sure that whenever we have a position open and we selected this position, and we added the code for this already in this for loop, so if we reach this point, we do have a open position selected, right? Then we can check if the TSL input variable is true. So if we want to use this TSL, then we will process a TSL. And we can, for example, say that we want to drag along the stop loss at the low of the last candle. So we can say, for example, double stop loss. The stop loss should be I low symbol time frame 1. What does this mean? So we know the I high function already, right? We used it here. So we use a symbol and a time frame to define the chart, and then a shift value to get the candle. Here I will choose the shift value 1, which means that this will always give me the low of the last bar in the chart. So not the current bar, but the previous bar. So we will have a look in the tester in a second, but what we want to check next is we want to check if stop loss is greater than the position stop loss. And we can get the position stop loss using the position get double function. This still works because our position is selected. So we just go for position SL as a identifier, and now we can check if this new stop loss or if the low of the last bar, if this is greater than the position stop loss. And in this case, we want to modify the stop loss of our position. Modifying the stop loss of a position, again, there are two ways. One is a little bit confusing and complex, and the second one is using the ctrade class, and we will use this, of course. So we say trade, position modify, and then we just have to say the position ticket of the position we want to modify. It is stored in our position ticket variable, so we will use this. Then we have to use the stop loss we want to use. Here we want to use the new stop loss that we calculated here. Then we have to provide the TP. We don't want to change the TP, so we will just use the existing position take profit. If I compile, that's a problem because this variable doesn't exist, but we can easily create it here. So we will just get the existing position TP from the selected position, like this. So now if I do another test, we can see if I turn this is TSL option in the inputs to true and start the test, we will see that first of all, we don't have a TP because TP input is now set to 0. And also, we will have this trading stop loss. Also, theoretically, you could set the stop loss for your position also to 0. It depends on your opinion if this makes sense to you. Most people say you should not trade without a stop loss, but it's up to you. You can code whatever you want. So here we see first position is here, and we will see it will most likely immediately place the stop loss at the low of the last bar. But in this case, it does not, because the low of the last bar is below the current stop loss, and we only want to trail in the direction of the trade, of course. So let's see what happens. I think this will be stopped out. Yeah, but we saw the modification there already. And let's wait for a trade that goes into profit. Let me fast forward so we can see this trade. And yeah, you can see the stop loss was modified. And yeah, this of course sometimes works better, sometimes does not work as good. But you could also say, like, for example, this was a very nice trade. You could say, for example, you want to have a trading stop loss puffer. Like, for example, input double TSL puffer %. Oh, it's buffer, right? In English, buffer %. And then we say like 0.5, for example. So we add another 0.5 or 1.0, whatever you want. You can set the stop loss, the immediate stop loss to 5% because we are using the daily time frame. So you can say it's really easy to play around with this. And now we can say, for example, we want to have the stop loss, which is I low, blah, 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 minus, yeah, let's just use the bid price, which we still have stored in the bid variable here. So we can say bit multiplied with TSL buffer percent divided by 100. And now you can see the trade has a little bit more room to breathe. And now you should start to understand what the real power of programming is in the MetaTrader 5. You can, besides the obvious fact that you don't have to sit in front of the PC all the time if you automated your program, you can also test so many different strategies, so many different combinations, so many different inputs in just no time. And now you can see, since I changed some of the values here and I modified the trailing stop loss, the outcome of this program is completely different. Oh, wait, I have to update the inputs. Defaults. So now the outcome of the program is a completely different outcome. It's pretty much a different strategy. So you can see you can test so many things and you can really find the strategies that work best for you and for your purpose, what you want to do. So let's wait until this test loads, and then we will see now the stop loss. The immediate or the initial stop loss is now no longer 1%, but instead it should be 5%. So the trade has a lot more room to breathe, which kind of makes sense on this higher time frames. Oh yeah, it was automatically modified already by the trailing stop loss. But yeah, the starting stop loss would be 5% otherwise. And here you can see now it is dragged along at the stop loss of the last bar minus 1%. So you can see trades have a little bit more room to breathe. Yeah, in this case, it was not really good, but we will see also trades that go into profit now with this newly adapted or changed trailing stop loss. And maybe there's, on the daily time frame, I think it doesn't make sense to use such a close stop loss if you really want to generate some huge profits and benefit from huge moves. Maybe the stop loss should be more like low of last candle plus 5% or something to really benefit from the huge moves. But yeah, you can just play around with this concept, of course. Also, I want to teach you some more things about programming. For example, how you can move parts of your code to different functions. And for example, we could see that for example, let's say we want to use this for loop in a separate function, so we can move it outside of this onTick function. Because so far we only use system functions that are part of the MQL5 framework, right? But you can also write your own functions. And this is what I also want to show you in this tutorial, because it will round up the most important basics about programming and MetaTrader programming. So we can not only use the system functions, but we can use and create our own functions. So let's go at the very bottom of our program, and here we can create our own functions. It has to be outside of existing event handling functions, so outside on a global scope. So here what we want to do is we want to say void and then, for example, loop trades. This is a function name that I usually choose. You can choose whatever name you want. And then you add round brackets and curly brackets. If you compile, you will see this works and there's no error. So what did we do? We first of all defined this function here. The function is usually defined by the signature first. The signature has three parts: the return value, the name of the function, and then the parameters. We know a lot of this stuff already. Like for example, if we have a look at the function that we already know, like for example the i-high, we know already that they have a return value, which is the value that is then returned after the function is finished. It has a name and parameters. So this is exactly what we also have here, but instead, that's different to the system functions, because for system functions in the reference, we usually do not see the body of the function. But for our own functions, we have to add the body so the program knows what this function does, right? It's pretty obvious, I think. So what we have here is, we do have a function that we can now call. So what I can do is I can go inside of my onTick function, which is called by the MetaTrader itself because it is an event handler. And I can say here, for example, loop trades. If I compile, no error, it works. What does this mean? It means that when the onTick function is processed from top to bottom and we reach line 37 in this case, and there is written loop trades, what the program does is it will search in the program code for this specific function. So it will go down here and it will find this specific function with this exact name. If I change the name, it does no longer work because this function does not exist. But if this function exists, it will call this function here at this point, and then it will execute whatever is written inside of the body of this function. So what we can do is, for example, we can move this whole block here, this whole for loop. We can cut it from here. Cut. And we can move it inside of the body of this loop trades function. So we paste it here. So now it is in the body of the loop trades function. And it is looping the trades. So it kind of makes sense, right? We can also say loop positions. I mean, it's completely up to you how you want to name it. But make sure to call it by its name if you want to call it. So if I compile it like this, now we get a slight problem. There are actually two problems, but we can fix them easily. Like the first problem is position open is an undeclared identifier. And you might ask yourself why. I mean, we declared it here, right? But the problem is, yes, we declared it here, but this is a matter of scope, what I tried to explain before. If we declare it here in the onTick function, it only lives in the onTick function, but not in the loop position. So if we double click this arrow is not here, but it appears down here in the loop trades function. So if we double click this arrow, we should jump here. Because here in this loop trades function, loop position function, this is not known. How could we fix this? We could say, for example, double is position open will be created here also. Now it also lives in the loop position function. The problem is, or let's do it like this, and I will show you what the problem is later. Then we also see another problem. Bit is an undeclared identifier. So it's the same problem. We use bit here in this loop position function, but we declare it here in the onTick function. So it's only known, it's only available in the onTick function. So in the loop position, we would have to do the same. We can copy this, and we can do the same thing here in this loop position function. If we paste it and compile, now it is known here also. So now all of our problems are gone, right? So let's do a test run and see if this works. And oh wait, let me show you one thing first. So let's move this away here. Let's comment this out. So now we do have the loop position function, but we never call it in the onTick. So what happens here? Let's do some tests. And this will, of course, not give us good results, but I think it's important for you to understand how this works. And afterwards, I will show you another interesting thing that you will maybe not expect. Because even if we do add the function to the code, it will still not work. And I will explain why. And this is a really good learning. So you will see we have the first position, and now there is one big issue, because after the first position, we also see a second, a third, etc., etc. We see so many positions. This is a problem we had before. And if we have a look at this code, it's completely obvious why this problem appears now, because is position open here is false, and since we do not call the loop position, it's never changed. So it's always false, and we always open more positions. So what happens if I now add this loop position to the code? Now this should fix our issue, right? Let's say, or let's test another let's do another test run and see if this will really fix our issue. And then I will show you another really important thing that you have to understand when you work with functions, and to make you understand this concept of access or scope. So here we will see there is our first position, and so yeah, actually my tester hangs up all the time if I do this specific test. But yeah, if I stop it, we can still see it still opens all the positions, just too many positions, and it's completely not correct, right? So why is this happening? This is happening because if we go back to the code, we can see even though we added the loop positions function here and we have the isPositionOpen variable here and we set it to true here, it still opens positions. And the problem is this isPositionOpen variable, it is a completely different variable than this one in the onTick. Even if the name is the same, for the computer, these are completely different variables. And we learned in the beginning, variables just point to a specific address in the random access memory, and this one points to a different address than this one. Because this one lives in the loop position function, yeah, and it is declared here. And this one lives in the onTick function and is declared here. And this one is never changed. It's never updated. In the loop position function, a completely different isPosition variable is updated. So what we have to do is, or what we can do to fix this, is we can say we want to return a, oh wait, this should be bool, right? This should be bool. We want to return a Boolean value. So if we compile now, we get a problem because it says not all control paths return a value. Which means if you choose a return value other than void, or I did not explain this by the way, void means a function does not return anything. But if you choose something else like double, int, or bool, you have to return something in your function for every possible outcome or control path. So for example, we can say at the very end of our function, we say return, which means we want to return something, and then we say what we want to return. And we return isPositionOpen, which is this variable and the value in this variable. So if we now return the value that is now stored in this variable, which might be true, we can use the return value of our loop position function and update this variable in the onTick function. Like this. So if we do it like this, now we can do the test again. And now this isPositionOpen variable in the onTick function is updated. And now, if I do the exact same test again, I did not change anything else, you will see that now it will work because the isPositionOpen variable is updated. And now after opening one position, we will not open more positions. So let me fast forward here until we see this in the tester. There is the position. And yeah, you can see I can make the backtest quicker, but we only have this one position and there's no other position until this one is closed. And then if we see another high, we will see another position. So this is how you can use your own custom functions and create them. And yeah, you want to do this if, for example, you have a block of code which is pretty obvious what this block does, and you just want it outside of your event handling function to make the event handling function look cleaner, or you often use functions if you have a specific part of code that you want to use multiple times, because I could use this loop position function multiple times, and I don't have to write the code multiple times because I just can call the position multiple times, right? There's also one more thing that I want to tell you. It's not really necessary that we do this, but I want to show you how it's done so you know how it's done. I want to create a a parameter for this function. And you can create parameters like this. In the round brackets, you can just add as many parameters as you want, and with different types, like this, for example, variable 3. Now we do have 3 parameters. And if we compile, we can now see this is the wrong parameter count for if we call the loop position. Because if you have parameters for your function, you will have to provide values for these parameters. So you can see now when I call the loop position function and I open these round brackets, I have to provide values. I have to provide a bit value, which is of type double. I have to provide an integer value, and I have to provide a Boolean value. So if I add these 3 values, the error is gone. There's another error which says bit is already defined. And this is because I create this bit variable again here in the loop positions, but it's already a parameter. So it's already defined here and I cannot define it again. So what I want is I want to delete it from here. Also, I delete these 2 parameters. They were just to explain how you can add multiple parameters. And let me also delete them up here. And now, instead of this value, I want to pass the value in this bit variable. So I can pass the value of this bit variable to the function, so I don't have to calculate the bit value here again. I just get it from the parameter. So the parameters are pretty much what you can give to the function to work with. And it can be 1, it can be 2, it can be 10. And the return value is what you can get from the function after the function is processed. So this is how it works. And you can only have 1 return value for functions, by the way. So yeah, if we do it like this, this is now fully functioning, and we can use this loop here to do what is necessary to be done, so our program works without any problems. And now you could use this program to do long-term backtests and test and see if you can find actual profitable settings. And actually, I'm pretty sure that you will find profitable settings for this, because the strategy follows long trends in indices or stocks, for example, that tend to go long. So this is how you can use this program. And also, you can also modify this program if you want. If you want to learn more about programming, like in this video, I covered some of the most important basics, but of course, there's a lot more stuff that you could maybe do more efficient, a lot more things you can do, you can learn. As I said before, check out the link in the video description and you will find my complete course. It's definitely worth it. I have so many students that are now creating their own programs, that use their programs, make money in the market, or that sell their programs. And that also, I also have students that already work for others as freelancers. So it can really change your life if you learn how to write code for the MetaTrader 5 platform. But yeah, you can see if I fast forward. Now, let me show you one example of a trailing stop loss so you can see everything is still working, even if we move the code to this loop trades function. And then as a last thing, I want to show you that code again, so you can copy and compare it to your code if you still have some errors. So yeah, you can see trailing stop loss is also working here. I don't know, my tester is really slow, so let's just have a look at the code again. And yeah, first of all, maybe let's move this out of the on tick. Maybe at the very bottom of the code. This was just a helper to understand how the loop works. And this is the helper for the parameter, for the variable data types and the operators. So yeah. Okay, so let's have a look at the code again. So at the very beginning, we had these properties, and these properties could be changed. It's pretty much just the information for the user. Then we have the include line here, which is really important because using this line, we get access to this trade ctrade class, which helps us to open, modify, and close and change positions. Then we have a bunch of input variables. Input variables are the variables that can be modified by the user. So for example, if you would now want to use this program on a real live chart, you will see that you have this inputs tab where you can see all the inputs variables that can be changed by the user. So this is what we use input variables for. And the program will then use the values that the user of the program decided he wants to use. Then we declare a global variable which is called trait, and it's of type ctrait. It's a so-called object variable because it's of like the type for this variable is a class. This is a global variable. It is global, which means that we can use it in all of our functions. And this is also necessary because in the onInit function, the function that is used or triggered when the program is initialized, we set the magic number for this trait object, which means every position that is opened by this trait object variable will have the magic number here. We do not use the onInit in this program, but it is triggered if the program is deinitialized. Then we have the onTick function, the one that is triggered with every single tick. Here, first of all, we get the index for the highest high in the last x bars. And x is defined by the count, which is an input variable. The time frame is defined by the time frame input variable, and the symbol here is always the chart symbol. Then after getting the index, we use the index to get the actual high price of this bar using the iHigh function. Then we get the current bit price of our symbol using the symbol info double function. Then we check if we do have open positions, and we check this using our own loop position function. We also have one parameter for this loop position function, which is the current bit price. So let's have a look at the loop position function, which we define down here. This function will return a Boolean value, which we need to check if a position is open. By the way, I could change this variable name here to, for example, check open position. And if I do this, I will have to change this name here also, and also here, because now the variable in this function is called check open position. And and the function here, the variable here is still named is position open. This should underline that these positions in fact do not have anything to do with each other. They are completely different variables. They point to completely different addresses in the random access memory of your PC. So yeah, here we just loop through the traits using this for loop. I explained it before. You always have the initialization, the main condition, and the part of code that is executed after the execution of the body of the for loop. In the body of the for loop, we first of all select a position at the specific index. We check if it's the chart symbol. We check if it's the magic number of our program. And if yes, we know this belongs to our program, so we update our variable that we use to check if there's an open position. And then if we use the trailing stop loss feature defined by this input variable, we also calculate the new stop loss and we update the position that we have here. Then we return the variable that indicates if we do have an open position, which will then be, as a return value, will be stored in this isPositionOpen variable here in the onTick function. We then use this isPositionOpen variable to check if we currently have an open position. We also check if the bit price is higher than this high price. If yes, we calculate the ask, the TP, and the stop loss, or the entry, the TP, and the stop loss for our buy position. And then we simply open this buy position using the trade object variable and the buy function. So make sure to copy everything 100% as it is here. Do not forget the semicolons. Do not forget anything, and it should work exactly the same. If you get any errors at this point, just check the code again. There is a problem in your code. It's not, you don't randomly get errors. I cannot really fix this error easily. You just have to copy the code. So, as you can see, this program is actually a really small program. So we have a total of, can I fit everything here? Not completely, but we have a total of around 70 lines of code. And there are even a lot of blank lines. So you can see it's a very, very short program. I know I explained everything in detail, and I think it's very important to do so for your first beginner tutorials, because then you really understand how programming works and why we do the things that we do. But Actually, if I would write a code like this just for myself, it would probably take me 10 minutes. So you can see, once you have the power of programming for MetaTrader 5 programs, it is crazy what you can achieve. You can test so many different strategies. You can write strategies for yourself. You can write strategies for others. You can sell them. You can do whatever you want. It's such a powerful skill. It's definitely worth learning. And again, if you want to have a shortcut, check out the link in the video description. And in the end, if you appreciate what I have done with this very long tutorial, please leave a like. It would mean the world to me. And recommend this video to your friends if you think someone else needs to learn some programming basics, or actually most of the necessary programming basics for MetaTrader 5 programming. So thanks for watching. If you are still around at this point, yeah, it's really a great achievement if you followed through the whole video. Thanks for being here, and I hope you learned something. I'm out. Have a good time. Good trades. Bye-bye.